To figure out how much signal you get from a certain tissue with certain parameters of a spin echo sequence, you actually have to do no more than combine its T1 and T2 curves. Here we have the T1 and T2 curves of a certain tissue. T1 represents the longitudinal relaxation, and T2 represents the transversal relaxation. Which parameter determined the amount of longitudinal magnetization? That was TR. To see how much longitudinal magnetization will be tilted 90 degrees to the side, and thus to figure out with how much transversal magnetization we start out with, we just look at the intensity of the longitudinal magnetization at the time TR. The longitudinal magnetization at this point, tilted in the transversal plane, is the starting point from which transversal magnetization decays. So, we just attach the T2 curve at this point. How much signal we get with a spin echo sequence to construct the image also depends on TE, the time that we wait after the 90-degree pulse. So, we now only have to look for the signal intensity at the time TE on the T2 curve. What image do we get when we choose a long TR and a short TE? Here are the T1 and T2 curves for two different tissues. As we heard earlier, with a very long TR, all tissues will have totally recovered their longitudinal magnetization. Differences in T1 of the tissues examined will not influence the signal, as enough time has passed by to allow even tissues with a long T1 to relax totally. So when we choose a long TR, as we just said, then differences in T1 do not really matter. When we also use a short TE, differences in signal intensity, due to differences in T2, have not had enough time to become pronounced yet. The signal that we get is thus neither T1 nor T2 weighted, but mainly influenced by differences in proton, or spin density. The more protons, the more signal, if you look at it simply. And what happens when we use a long TR and a long TE? With a long TR, there are no prevailing differences in T1. With the long TE, however, differences in T2 become pronounced. Thus, the resulting image is T2 weighted. What if we use a shorter TR and a short TE? With a short TR, tissues have not recovered their longitudinal magnetization. Thus, differences in T1, which determines how fast longitudinal magnetization is regained, will show up in form of signal intensity differences. When TE is short, differences in T2 cannot really manifest themselves. So the resulting image is still T1 weighted. There is a lower limit for TE because it takes some time for the 180-degree pulse to be sent in and to properly take effect. What if we use a very short TR and a very long TE? This is only a theoretical question. Why? With a very short TR, there will only be very little longitudinal magnetization which is tilted. And with a long TE, we even allow the small amount of transversal magnetization resulting to disappear to a large extent. The resulting signal will be so small, of so little intensity, that it cannot be used to make a reasonable image. If you've not been concentrating for the last few minutes, you're probably thinking about giving up right now. How to remember this? Even if you don't understand all of it, which hopefully is not the case. Try looking at this illustration. What can you see? A man with short trousers. And considering the weather conditions, this makes only one person in the picture happy. This should remind you that a short TR, trousers, gives a T1 weighted image. Only one is happy. And what can you see in this illustration? The same couple is having tea. Now, having tea, which is usually served hot, always takes a long time. And in the illustration, the long T makes two people happy. This should remind you that a long TE gives a T2 weighted image.